There are many organic structures, many, and thousands of them have their own special names. For example, aspirin. We all know what aspirin is, but as a chemist, we don't know what aspirin is unless we've memorized the structure. The word aspirin doesn't tell us anything about the structure. And so it goes for the tens of thousands of compounds that have special names. This is just not satisfactory. You shouldn't have to look a structure up in a book or memorize thousands of them to be able to know what the structure of an organic compound is from its name. There's got to be a better way. And in fact, there is. There's a group of chemists called the International Union of Pure and Applied Chemists that developed a systematic way of naming compounds called the IUPAC system. And that stands for International Union of Pure and Applied Chemists. And let me just summarize what this IUPAC system uses for an approach in a general way, and then we'll look at a specific example to illustrate. The approach is take the core name and use it to tell us the number of carbons. Add to the end of that another part of the name that tells us what the functional groups are in that molecule. And then out in front of it, add a third piece of the name that's all the other stuff. IUPAC name, a systematic name, tells us the number of carbon atoms, and specifically, this is the number of carbon atoms in the longest chain. We know what the functional groups are, and we know what else is attached. Other alkyl groups, halogens, whatever. Well, we can use this system if we know the names that tell us what the number of carbons are. We can use this system if we know the names of the functional groups. And we can use this system if we know the names of all the other stuff. Now, those pieces we have to memorize, but it's not a long list, and we use them over and over and over in a systematic way. So it's worth memorizing. I have summarized that list here. The specific, and by the way, you can find this information in textbooks and other summaries, so you don't need to copy all this down. But basically, I've summarized the names we use to indicate the number of carbon atoms, 1 through 10, in the longest chain. And chains can be much longer, but let's limit the aspiration in terms of memorizing names to the first 10. And they aren't so difficult because many of these words come from root words that you know, like penta for 5 and hexa for 6 and hepta for 7 and octa for 8. Those things you know. So that's not so difficult. And then in addition, these alkanes can become alkyl groups that are attached to something by simply removing a hydrogen. And so we need to learn the names of those alkyl groups for a certain small set. So if it has one carbon, we call this a CH3 group, methyl, 2 carbons, CH2, CH3, ethyl. If it has 3 carbons, there's 2 possibilities. It's either N-propyl, a straight chain with something attached here, or isopropyl, a chain with something attached in the middle. And I have rewritten this isopropyl group in this form, and you'll see why in just a second. So these 2 structures are the same thing. We also should memorize the butyl groups. Butane, 4 carbons, nothing but carbons and hydrogens and sigma bonds, where 1 hydrogen has been removed to make one of 4 possible alkyl groups, butyl groups, and here they are: N-butyl, isobutyl, and that's why I wrote the isopropyl this way. All the iso compounds end in CH with 2 CH3s attached. Here's one, here's another example. A third butyl group is called secondary butyl, and that's with that attachment here. And a fourth butyl group is called tertiary butyl, and it's attached to a carbon that has 3 CH3s attached to it. So it's 4 carbons. And so we can use these 10 names here as our central core of telling us how many carbon atoms are in the longest chain. And we can use the names of these alkyl groups that I've given here to tell us what's attached to those chains, along with halide and other things. And then we can append at the end names for the functional groups. Well, the good news is that for alkanes, we don't need to do that. There's none. So we will use at the end of the word ANE we will use this root name to tell us how many carbons in the longest chain, and we will tell us ahead of that what other stuff is stuck on that chain. Here's an example. So we've got a chain. Got themselves stuck to it. And to name this molecule, which we see as an alkane because it only has carbons and hydrogens and single bonds, we need to identify each of the carbons in this molecule. So let's do that. And I'm going to put a dot where each carbon is. And now our task is to identify the longest chain in this molecule. And when we look at it, we easily see a straight chain, 1, 2, 3, 4, 5, 6, 7 carbons. But that's not the longest chain. If we start here, 1, 2, 3, 4, 5, 6, 7, 8 carbons. But if we didn't go here, but we went here for 8 and this for 9, we would say that the longest chain is actually a 9-carbon chain. Let me draw it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we need to go up here and look at the name for a 9-carbon chain. Here it is, no name. So we're going to put in the middle of this name, no name. We're going to use the ANE ending because it's an alkane. No functional groups. 9 carbons. And then we have to say out here what the other things are that are stuck to it. Well, let's take a look. Let's find them. There is a CH3 here. There is a CH3, CH3. There is another CH3. And there's one more. Well, we have two kinds of groups attached here. We have methyl groups and isopropyl. Now, what I haven't told you yet, and we must know, is that these groups are placed ahead of this name in alphabetical order. And this is a CH3, and this is a CH with two CH3s. We go up and take a look at our list. CH3 is called methyl, and the CH3, CH3 group, either written like this or this, is called isopropyl. So we have an isopropyl group and a methyl group. I comes before M, so we're going to put the isopropyl group first and the methyl group next. So the methyl group will come afterwards. Let me write it in here. And before that, isopropyl. Now, we haven't said yet that there are 3 methyl groups, but there are. So we better put trimethyl here. Tri meaning 3. And what remains is for us to say where these methyl groups are. So we need to number this 9-carbon chain we've got. Let's do that. And we will number from the end, where when we start along the chain, we first come to an attachment. In other words, the end where there's an attachment closest to the end. Here we go 1, 2, 3 carbons before we get to something. Here we go 1, 2 carbons. So this will be the end we number from, 1. And we'll number every carbon. Now we can say that those methyl groups are in the 2, 3, 7 carbons. 2, 3, 7, trimethyl. And what we now have to do is say where the isopropyl group is, and that's on the 5th carbon. So here's our systematic name. It's a nonane. It has 3 methyl groups. It has an isopropyl group, and it tells us exactly where they are. And we know which end of the chain to number from, because that's the end that has an attachment closest to it. So this IUPAC systematic name will let every chemist in the world draw exactly the same structure. And we will use this systematic approach to naming organic compounds time and again as we learn how to name more complicated compounds with functional groups and other substituents attached. But it will always be the very same system. We'll find the longest chain. We'll use a name that tells us the number of carbons in that chain. We'll put the functional groups on at the end if there are any. Otherwise, if it's an alkane, we'll say A and E. And then we'll put all the other stuff in alphabetical order here, ahead of the name, using numbers to tell us where those things are.